Crime scene reconstruction, really an important part of our job at the crime scene. If we just expect that all we're going to do is show up, take some pictures and bag some evidence, then we're going to be doing a really poor job. There's so much more to it. There's all the walkthrough and understanding the scene and coming up with conclusions based on your evidence that may support or refute statements or theories, all sorts of things involved. And one of the big things that often is overlooked is crime scene reconstruction. Or with crime scene reconstruction, we need to do this before we start collecting our evidence, or at least we need to plan it before we collect our evidence. So let's step back and ask, what is crime scene reconstruction? It is the use of scientific methods, physical evidence, deductive reasoning, and their interrelationships to gain explicit knowledge of the series of events that surround the commission of a crime. So we're going to use everything that we see and have in front of us and our reasoning to try to determine what were the events, what occurred based on all that we have there at the scene. And to do that, we have to make sure that we are considering this before we collect any evidence, because often the evidence is there to show us what occurred. A really good example is firearms trajectory. If we have a bullet passing through an object, and that can now show us trajectory or the path of the bullet, if before we even consider that, we collect the item that has the bullet hole in it, now when we think about, oh, we should do trajectory, we can't recreate that because we've already moved the object that had the bullet hole in it. What kinds of things can we use crime scene reconstruction? Well, bloodstain pattern analysis is a big one. When we look at a crime scene and we look at the bloodstain patterns, they can tell us quite a bit about what occurred. They can give us identity, whose blood is it, so we know who the bleeding individual is for the different stains that we're looking at. The positions of individuals, we can determine the position of a victim or someone who has been injured based on the bloodstain pattern that is then developed. The number of blows that occur. If I see a lot of blood stain, the first thing I do is I look for patterns, obvious patterns. So here is a cast-off pattern, and this appears to be from one weapon, one event. Now, if I see another cast-off pattern in another location, I say, well, here we have another event. So when I at least when I sample the blood stain, I'm going to sample from both. If the cast-off patterns were together, they were parallel, it would look like they were all one event. Well, then I may only sample one of them for a blood type, for DNA. And when you're looking at patterns, you look for things that don't quite fit. So I had a scene where I identified several patterns, and then there was this one drop of blood. It was kind of off by itself. Now that's not unusual, because you'll get stray things coming from another pattern. But I looked at that and said, that is a little too unusual. I'm going to sample that. Turned out to be the suspect's blood. Often during these types of events where there's blood stain, the suspect is going to get injured as well, especially with stabbings. And it turned out that was the suspect's blood. Fortunately, I know the patterns and I can identify them, and that helped me to further document. Sometimes you won't have an expert who can come to the scene while you're there, so you have to document it thoroughly, and then the expert can look at your documentation to make determinations. And that goes for firearms too. Firearms is another classic example of reconstruction. We can determine trajectory. Now, we use that word a lot, and I really don't like it, because trajectory also takes into account the fall of the bullet or the projectile due to gravity. And we normally don't take that into account because our distances are quite short. But even on a short distance, I suppose you should take that into account if you're trying to find true trajectory. So what I prefer is bullet path. And if I testify, I will avoid using trajectory. I'll say bullet path instead. Now, I suppose if we had a sniper incident where someone fired from a long distance with a rifle or something, then we would take that into consideration. But actually, what we do all the time is we deal with straight lines, and we always say approximate path. We never say this is exactly how it happened, because there are too many variables where we could be off slightly. So we always say approximate. We can determine shooting distance. How far was someone from an object when they fired the weapon? Or how far were they from the victim or the other party? And then another example is glass fractures. There is a whole science to that also. You can determine the direction of the impact by looking at the glass. You can look at the glass on the side and see the stress marks and know which direction the force came to break the glass, because the glass actually bends before it breaks, and those stresses will be there and you can see it. Sequence of bullet holes, things like that. And that's really simple to see. But what we want to do right now is get right into some reconstruction and talk about firearms reconstruction. What kinds of things can we determine in a little more detail? Well, the approximate number of shots fired, we can determine that by looking at the evidence. How many bullet holes are there? How many wounds are there in our different victims? Or maybe they're suspects that are wounded, individuals. So we can determine the approximate number of shots fired. We can also determine the direction and distance from which shots were fired. We'll see how to do that. Who fired which shots? And sometimes that's just common sense again by looking at the evidence, but also looking at the evidence of the firearm itself. Do we have fingerprints and DNA on the firearm? Do we have gunshot residue on the hands of someone who shot the gun? The sequence in which shots were fired. Often we can determine that by looking at all the evidence, which came first. Sometimes it's very obvious. We can also relate the shooting to other items of physical evidence, such as bloodstain patterns. Gunshot residue on the hands. There's all sorts of evidence here. When we do that GSR test, we might be able to tell that this person either fired the weapon or was near a weapon that was fired, but that could be quite helpful. This is a revolver. This is a pistol on the right. And then we also know about the cartridge case ejecting from the right-hand side of most semi-automatic pistols and to the rear of our shooter. When we find a cluster of cartridges, that may help us determine where a shooter was when, or where the gun was when it was fired. Now, again, we can't hang our hat on that all the time because these cartridge cases are lightweight. They will bounce around. If the wind is blowing, that can move them as they're in flight because they're very lightweight. And during a scuffle, during the response by police officers trying to come into the scene, things can get kicked, but sometimes that can be helpful for us. Now, let's talk about distance determination. Let's say that we have some gunshot residue on a surface. Maybe it's on the clothing of our shooting victim, and we have a pattern that we can see. Well, what we need to do if we want to try to determine the approximate distance that the gun was from the victim at that time the shot was fired, we have to do some steps. First of all, we have to have the suspect's gun. If you have a shooting and you don't recover the firearm, but you have gunshot residue on a surface or a person's skin, yeah, the pathologist can give a ballpark. This is characteristics of a close range shot and be vague like that. But if we want to be a little more specific, we need to have the suspect's gun. So we get the suspect's gun. The next thing we have to make sure we have is the same ammunition as was fired. Now, if there's still some ammunition in the gun, we can't use that in our testing because that's evidence. So what we need to do is get some ammunition that is the same brand, same model, design, everything. It has to be the same ammunition as was in the suspect's gun when the shot was fired. We have to get our own so we can do our test firing. And because of that, all of the firearms examiners that do this kind of testing, they will have a cabinet full of different cartridges, boxes of cartridges. And when some new kind of cartridge comes out, they usually buy a box because you never know when you're going to need it, and who knows if when you need it, it's still available. And then we just go ahead and fire. Over here on the right hand side, you see this is an indoor range for the criminalists to use. So you set up targets, shoot from different distances until the pattern you create matches as close as possible the pattern on your evidence. So if you have a certain size pattern on the victim's shirt, you're going to shoot from different distances until you get approximately the same size pattern using the suspect's gun and the same ammunition. We're still going to say approximately because there are variables. If it was outdoors and the wind was blowing, not all the gunshot residue may end up on the victim's clothing. So we always say approximate. And one other thing that I think is important is we always choose a material to shoot in that is very similar to our evidence. If you shoot into a t-shirt, your result is going to be a little different than shooting into leather. So if the person was wearing a leather jacket and your gunshot residue is on a leather jacket, you're going to want to shoot into leather as well. And it just makes it easier to convince people that what you did was on the up and up and made scientific sense. Now, occasionally, some of our gunshot residue is hard to see. So just imagine if you have gunshot residue on a black leather jacket. It's going to be really hard to see. So how do you do that? Well, really, the best way to visualize gunshot residue on dark surfaces is to use UV photography. So I think what I want to do right now is actually show you an example of one of these tests. Here is a sheet that I shot into with a real flimsy material, a short range shot. The gases as well as the gunshot residue are just going to blow the piece of material apart. You can see here how I fired from 1 inch and it just blew this material apart. But what I'm looking at here that's more important is the pattern itself. So we have this nice large pattern at 1 inch. Then I have another one down here, and this is 6 inches, and the pattern goes right about in here. What I really can see here are some of the little specks. So that would be some of the unburnt gunpowder. I've never had a situation where there hasn't been unburnt gunpowder in something like this. So when a firearm fires, not all the gunpowder is going to burn. Sometimes little specks come out. And so that's what we have here, as well as the gunshot residue. Sometimes you'll have little burn marks, and that would be burning gunpowder. Now, this would be 6 inches right in this area here. All right. And then this one is 24 inches. And really, there's just a couple of little tiny dots and nothing else. So that gives you an idea of what kind of results you can get from different distances. And that was using the weapon you've seen me demonstrate with, a 40 caliber semi-automatic pistol. And it gave this kind of a result shooting into a sheet. I would like to point out one other thing. On this one, you do see a circle where the bullet went through. You can also see it right here, this little ring. That is called a wipe. It's when the material on the bullet, so when the bullet is leaving the barrel of the gun, some of that gunshot residue is actually in front of it. There's also material inside the barrel that the bullet picks up. And so the bullet itself is going to have residue on it. And usually the first object that it passes through or into, it's going to wipe that off of the bullet, and you're going to have that little ring like that. So if you see that ring, typically that's the first time the bullet touched something after it went out of the barrel. And then if you see another hole like that, but there is no wipe, it is likely that it's already passed through something before it hit that. So that's something to be aware of. So there is an example of our distance determination. So if I had an article of clothing and I put it alongside and it looked something like this, then I would say approximate distance was 6 inches. Or I might use a range, approximately 4 to 8 inches. This is the LA Sheriff's Department's part of their reference library for firearms. And you might be wondering why they have all of these. Well, there's a couple of reasons why. One is for training purposes. It's also good in case you have a gun in evidence that you have no clue what it is. Maybe some of the manufacturer's markings are all filed off. You may not even know what maker it is. Well, you could then go to the reference library and see if you can find a gun that matches, that has all the manufacturer's markings on it, and then you'll know what it is. Or you might have a gun that has a serial number filed down. So you're going to raise that serial number. But you may need to know, what am I looking for? Are there letters and numbers, and how many are there? So you can go to the reference gun in your library and look at the serial number and say, okay, that's where it needs to be, and that's what it needs to look like. It could also be that you have a damaged evidence gun. Let's say the bad guys pulled a robbery, they're being pursued by the police, they throw the gun out the window and it gets run over by a semi and now it's damaged. Well, you might need to test fire that weapon, but it's damaged, so what do? Well, it still has to be that weapon you test fire. So you could go to the reference library, find the same weapon, and take parts from your reference gun and repair your evidence gun so you can fire it. How do they get all these guns? Well, often they are evidence. You can also petition the court to retain the guns for training or for evidence purposes. And so that's how they get these libraries established. Now, I mentioned that they can have cabinets full of ammunition. So this is LASO, and they've got, this is just a couple of their, I only got a portion of the cabinets, but they have all sorts of ammunition there. So they have it on hand if they need it. Now, this is a bullet recovery tank. Let's say that you do want to compare a bullet that you have recovered from the crime scene or from a victim's body with a bullet that you test fire from the suspect's gun. So once again, you need the right ammunition, and then you need to test fire the gun and retrieve the bullet. The way we normally do it, with some exceptions, now there's some bullets you can't do this with, some rifle bullets, but almost all you can, all ammunition. You just fire into a tank of water. So that's what this is. This is a big water tank. Here's an opening right here that you place the barrel of the gun in, and you point it in there and pull the trigger. The firearm discharges, the bullet goes into the water and is slowed down and just falls to the bottom of the tank. The reason there's a net right there is if you're firing a semi-automatic pistol, you don't want the cartridge case that is ejected just to bounce around the room and then you're looking for it underneath the machine and all that. You might need that cartridge case as evidence as well. You might be doing a comparison with the cartridge cases you found at the scene. So you want to be able to capture those without losing them. And then there's some controls here. The lid opens and there's a screen that lifts up the bullet and you can retrieve it. Once you have the bullets or you have cartridges that you have test fired, there are comparison microscopes. There are systems like brass tracks where you're tracking the brass, and the brass is the cartridges that they gave it a name, that these criminals will use. Here's a simple one. They're looking at the base of the cartridge to see if the breech face markings match from a cartridge found at a crime scene to a cartridge that was test fired in a suspect's gun. So they put the two cartridges under the comparison microscopes, and then they turn them and line them up until they see if they match. In 1930, we have this photograph. What we have is a bullet hole, or where a bullet came to rest. It was lodged in the side of this gas station. And in the car here, there's also a bullet hole. Quite simply, all that was done to show the path of the bullet is the string is attached where the bullet terminated, and it's pulled through the hole in the car, and it happens to go through the window here, and then this trooper is holding the end of the string to make it in a straight line. And that gives us an idea of the bullet path. So the question would be, where was the shooter? Was the shooter here? Was the shooter over here? Was the shooter here, or here, or here? Well, the answer is, unless we have other evidence, the shooter is anywhere between where that bullet hole is and where this string goes into the ground. That's really all we can say. And that's all we should say unless there is other evidence. Now, when we do that, rest assured, the jury is going to make their own conclusion where the shooter was. They'll look at it and they'll use their logic and maybe other evidence about it, and maybe the testimony that they hear, and they'll say, yeah, that guy was right up there at the window, and that bullet went right through the car and into the wall of the gas station. But we're not going to say that unless we have other evidence. Well, whatever other evidence could help us? Well, let's say that there is a victim laying on the seat and there's a bullet hole in the left side of the head and gunshot residue all around the bullet hole. Well, then we could say the suspect was probably right here and held the gun close to the victim's head and fired, and it went through the head and through the car and into the wall. Now we had more information. Or maybe we have a witness and we can say, based on the witness statement, the shooter was somewhere along here, but would be in line, the firearm would be in line with this, approximately in line with this string. So we have to be conservative. Here is a way we can document some of this also. Now this is done with rods. They come in short sections that screw together. So like this is 1, 2, 3 pieces here. Here we have what appears to be shooting from outside the vehicle into the vehicle. Points of interest and things we don't collect, we can give a letter to. So here, we're not collecting bullet holes. We're showing bullet paths. And so we're going to say bullet path C. And so you have C1, and then probably on the other side, we have C2, wherever that bullet ended up. And then here we have D, and here's D1 is where the bullet came through the car door here. D2 would be on the other side of this portion of the seat. And then D3 is where it came through the seat here. And then we have E1 where the bullet passed through this part of the door, and E2 where it went through this part of the console. And then we probably have F over here. So this is how we would document. Now, when we document these things, including the string, we have to take measurements as well as photographs. So we have to measure where these are and what the angles are. Sometimes we will have bullet holes in glass, like in a car. Typically, when there's a bullet hole in a windshield, the windshield does not shatter and fall apart. Windshields are laminated glass. So they are glass, but the inside and outside are laminated with plastic. And that gives it more durability. And when a bullet passes through, you're going to see the bullet hole and the glass is going to be pretty much intact. Often, bullets don't pass through windshields. Now they certainly can, especially if they're high velocity, but often they'll glance off the windshield because the windshield is sloped, and a bullet being fired into a windshield will be deflected by the glass. This is a side window, and they are tempered glass. Now with tempered glass, the glass, when it breaks into small chunks, or it cubates. Other glass, like normal residential window glass or in a picture frame, it breaks and it can be really hazardous, all the pieces, the sharp pieces. But on cars, there'll be tempered glass. On a sliding glass door, it'll be tempered glass, and it'll break into pieces like this. So what you sometimes find is a bullet hole, and you have all of this cubating occurring, but it has not fallen apart. Well, what you want to do is get out a straight edge or a string so you can mark vertically where that hole is with marks on the door. So I will take maybe a plumb bob that's going to have the weight on it so you can have it straight up and down. And then I'll mark with my Sharpie here and here. Then I will take a straight edge here. And for that, I need to use a level. And I will make that level. And I'll put a mark here and here. Then later, if that glass happens to break, I can still pinpoint where that hole was. And that could happen. That could break in moving the vehicle to the crime lab or to your impound yard, or it just happens at some point. And then you just tape strings and then you've got it. Another thing with vehicles, when we are going to document, and I noticed that there were these bullets that passed through the seat. Well, when you move the vehicle, sometimes the tow truck driver may move the seat, or searching the vehicle, someone moves the seat. Well, for trajectory analysis, you don't want the seat moved at all. So what I would tell people is, don't move the seats until we can do some trajectory analysis. Tow truck driver, to get that on your truck, don't move the seat. Or if you think that might happen or that's going to happen, you can put markings on the side of the seat. So if this is a seat that the top part slides forward and back, it's a motorized power seat, or the top tilts, you may be able to make markings so that later you can reposition it. As we have these rods, I mentioned we have to take measurements. So one thing we're going to do is measure the angle. So this is called an angle finder, but this actually will then give us the angle that this bullet path is showing. Another way you could do it is actually to use a protractor. But if you're using a protractor, keep in mind the sides of these cars are not straight up and down. And so what you need to do is actually use a plumb bob so you can make a straight up and down line, and then place your protractor against it, and then you can see what the angle is for your bullet path or your trajectory. This kind of gives us an idea of the bullet paths. These are just using whatever was available, and this is just showing one small area. So these are just those sticks with the flags on them that we can use for marking evidence outdoors. Here we have some rods. So you can see these went through the seats. Here are more. Now, what they did do is they wanted to have lasers. Here are some of the pictures with the lasers. All right, so I want to show you some of the tools and demonstrate them. So this is a laser trajectory kit. So here is a protractor. It's got lasers. It's got the rods that we were looking at. And probably the best way to show you this stuff is to actually try it out. So what I have here is a portion of a wall with 3 bullet holes in it. That it's easy to tell the entrance from exits in most things. These are all entrance. You see the nice round circles. And then the exits, the other side here, they're all raggedy and pieces hanging out. But you can see quite easily the exits compared to the entrances. All right, so as far as trajectory, we need to remember we need to have 2 points to do a straight line. So we have to have where a bullet passed through 2 objects, or it passed through an object and lodged into another, like it embedded into a wall. Walls are fantastic. If the bullet passes through both portions of the wall, you can do a trajectory with a wall because you've got the studs between 2 pieces of drywall, and so now you can make a straight line. So to show this straight line, all we really have to do is take one of these rods and put it through one of the holes. I think I'm going to choose this one right here. So you put the rod through. Now I got lucky that time. Sometimes you go, where is that? And unlike my display, you can't just put your head on the other side and look through the hole. You know, you're on the other side of a wall. So what you can do is have somebody else with a flashlight on the other side shine a light right there, and then you can see where the light's coming from and put the rod through. All right, so we just put the rod through, and that will help us to see the angle or the bullet path. But notice the rod can bounce around, it can move, and when it moves that much, it can throw things way off. What do we do about that? Well, these kits come with these cones that you slide on either end. So there's a couple different sizes, but you slide a cone on this end, so it goes into the hole, and then a cone on the other side into that hole. And that now makes the rod stay in one place. Then if you're going to tie a string onto it, the problem is when you make the string tight, the rod can slide. So you have these little grommets that come in the kit. And so we put those on there to keep it from sliding. Or if it's at a steep angle, you don't want it just sliding as you're trying to figure out your trajectory. What we need to do is some measurements. So one of the things would be to use the angle finder. You just go ahead and you set this on here and you wait for the needle to stop moving, and you see what angle in degrees our rod is at. Now another way you could do that is to use the protractor. And so for that, you would have to center this and then go ahead and read the angle. So I can read it from this side, and I'd read the angle here. So you could do it that way. But we need the vertical angle, but also we need the horizontal angle. So you are going to use this, even if you had this, you're going to use it for the horizontal. So you have to position this right under the rod and look down. Now, if it's at a great angle, a steeper angle, what you want to do is use your plumb bob to find out what angle is reading here. So you just go ahead and put that as you see here, and then read the angle. If you're doing it this way or this way, is use a level to make sure that your protractor is level. So you'd actually have a level and get it at the right angle as you're working. All of this so that you are as bulletproof as possible in court. And then they do make electronic levels. So with this, I can put it on here and it's got a magnet. And so I can read the angle digitally. Another thing we're going to do is we're going to measure how high this bullet hole is from the floor with our tape measure on this side of the wall. We'll go to the other side of the wall and measure also. And then we will measure from the rod to the nearest wall. So we have the height and the location from the next wall. Now we have angles, we have the measurements where the holes are physically in the room, and that's going to help us later, especially if we put all this into a computer program to try to show something 3D and we have the angles and so forth. So that's all the measurements that we have to do. Now, the next thing is to maybe show this visually in some manner. So one way we can do this is with strings. This kit, and it has different strings in here that I can use to illustrate the bullet path. And it comes with, if you buy a kit, it comes with different colors. So I've got red and blue and pink and lime green. You can choose a color that will show up in your photograph. So you don't want to choose a color that blends with the background. If I'm in a pink room, I wouldn't use the pink string because you wouldn't be able to see it in the photograph. I would use one of the other colors. The one I like the most actually is this one. It's a reflectorized string. Woven into the string is a reflectorized thread. And so when you have this string out, all you have to do is take a flash photograph, and the light from your flash bouncing off of the reflectorized thread makes a white line. So you see a white line where your bullet path is plotted. Now, the shooter may be right here, but what you want to do is pull out a string and terminate it wherever it goes to illustrate that path. And then you can say the shooter was closer or further back. Also, let's say you have a steep angle. The angle will get so high at some point where it's just not logical that the shooter could be shooting from. So that's another thing that's taken into account. But let's just go ahead and illustrate where this is by putting a string out. And really the easiest way to do this, the most effective way, is not to eyeball it and stick your string where it should go, because you could be off by a little bit. The best way is to start out with a laser. So I'm going to go ahead and put a laser. So now I have the laser on here, and it shows me a dot on the wall. So what I'm going to do is, in the kit, I have these little anchors that has an adhesive to them. So this little clip here has a gummy adhesive on the back. And so I just go over here to where that dot is and place it on the wall. All right. Now I can take the laser off and then put my string on and take a picture. So for this, I think I'll use a dark string. So I'll use this blue. So I take this little screw device off of this end and of this. And now I can tie a string onto it. So I have my knot. So the string's coming out straight. And now I just take this string and I go to that anchor on the wall. And then you just tighten it. Basically, you just wrap it around that a few times and it stays very nicely. And now you have your straight line that you confirmed with the laser. And then you can go ahead and put a second rod in a second hole and run it and so forth. So there's how you can do a trajectory setup, be able to see what your results are. And then you document them. And of course, you would photograph this as well as all those measurements that we took. I would also measure over here where the termination was. So I'm going to measure how far from that wall and how far from the floor and document where that termination point was. Now that might not be where the shot was actually fired from. Obviously, it'd be kind of hard to do that. But again, if you're putting all this into a 3D program, having all those measurements will be quite handy. Let me go ahead and put the laser back on again. There's two ways that we can photograph this with a laser. One way is to use photographic fog. So the photographic fog comes in a can. To do this, we have to spray the fog upward. What happens is the fog goes up, and so the particles are in the air, and then the fog is coming back down, leaving more particles in the air, and then you can photograph that. The other way to do this is to use a white card that you move along in front of the beam. So you'd set up your camera and you'd lock open the shutter, and then you cannot see the beam. So you have to show the camera the beam by making a dot on a surface. So here's the beam, and in the dark, you go ahead and move this along like this. And then you close your shutter, and now you have the beam showing, and you won't. So this is one taken with that ladder technique where you're moving the card. This is a darkened room, and I open the shutter, so the flash fires. But notice it's a little dark. I underexpose purposely, and then the shutter is locked open. After the flash happens, the room is now dark because all the lights are off, and I can actually walk through the scene with a white card reflecting that dot back toward the camera. And then when I'm done doing that, I close the shutter. And here is another one